All right, let's do this. Okay, so adding and subtracting polynomials. We had this polynomial definition from before, so we're talking about that the exponents have to be positive integers. And then there was a question last time. In the last class, if you have this, okay, that exponent is positive, but it's in the denominator. And so that, by definition, that means that it's actually a negative exponent. So if you have a positive exponent in the denominator, that is not a polynomial. Okay? So they have to be positive or zero. It could be a zero exponent or positive, okay, for it to be a polynomial. In the last section, we said there could be only one variable, but that was because we were graphing. Okay, we don't have to have one variable for polynomials for this stuff. Okay, so a little bit different. And so then these first couple definitions are basically saying, can you count terms? So what's a term? How do you know a term when you see one? So like if you're looking down here at this one I underlined, how many terms are there? How many? Three. Why is there three terms?
There's two like signs. Right.
Yeah, okay. Yeah, so they're broken up by a plus and a minus sign. And so that's how a term begins and ends. Is that okay? All right, so then there's three terms, so we call that a trinomial. If it's one term, you call it a monomial. If there's two terms, you call it a binomial. Anything over a trinomial, you just call it a polynomial usually. But all of those are polynomials. Okay, so what's like terms?
Terms are the same.
So what does that mean? How do you know when terms are the same?
Have the same variable.
Same variable, exactly. But what else?
Sign.
No, that sign doesn't matter. So you have to have the same variables exactly.
Integers.
They don't have to be integers.
Exponents.
The exponents also have to be exactly the same. Okay, then they are like terms, and we would combine them by adding and subtracting. Is that okay? And then they got this thing, and so then here they say you can add them and subtract them. Okay, so again, we're just combining like terms. Please watch your signs. And then down here, this is a term you guys probably never seen before, I'm guessing. So the set is closed if and only if an operation on any two elements of that set produces another element of the same set. I'm going to give you an example to make sense of this. But it says because adding or subtracting polynomials results in a polynomial, so the answer is still a polynomial, the set of polynomials is closed under the operations of addition and subtraction. So let's look at integers. We talk a lot about integers. And so if you add two integers together like these, this would be 7. Do we get another integer?
No.
Well, it's the question is 7, if 3 and 4 are integers, is 7 an integer?
Oh yeah.
Okay, so then that means since it produced another integer, then we would say that the set of integers is closed with in terms of the operation of addition. So if we subtract them, is -1 an integer? Yes, it is. So then since two integers subtract to give you another integer, then that means that the set of integers is closed in terms of subtracting. If we multiply them, do we get a integer or an integer?
Yeah.
So then the set of integers is closed when it comes to terms of multiplication. If we divide them, do we get an integer? No, we don't. So then integers are not closed in terms of division. Is that okay? And so then what they're saying with that first statement about being closed is every time we multiply, they just said add and subtract. As long as we are adding and subtracting two polynomials, we'll always get a polynomial. So then that set of polynomials is closed with addition and subtraction. Fair enough. All right. All right, so we got a lot of notes today. You'll still have like 10 minutes to get the work done, but then we're done with the notes for this section, okay? So part A here, so it says, determine whether each expression is a polynomial. If it is, then state the degree of the polynomial. So the degree changes a little bit here in a second. But I was told that we didn't do this, and you don't know this. But the cube root of x means that the exponent is 1/3. And since that is not a positive integer, that means this expression is not a polynomial because the cube root of x is not a monomial. And so you need all monomials inside your polynomial for it to be a polynomial. All right, so part B, right? We're not worried about there being multiple variables right now. That was only when we were graphing. So since we have all positive integers, or non-negative integers rather, then this is a polynomial, even though there's more than one variable in there. Okay, and so then the way they want you to think about it is the expression is a polynomial because each term is a monomial. Now in the last section we were talking about degrees of monomials or terms is just the value of the exponent. And then we said of the polynomial, it's the biggest exponent. So these rules are basically still true, but when you get more than one variable, the degree is the sum of those exponents. And then another thing I'm going to say here is it's also alphabetical. So since A comes before B, you list all the A terms first, even though the B term has a bigger exponent. Because it's the term with the biggest exponent with the A variable, and then you do all the A's until you're done with A's, and then you move to the next variable. Okay, so that's why this is in standard form right here. Okay, so then the first term, right, the A has an exponent of 4, the B has an exponent of 1, so then that's how we get the first term having a degree of 5. Is that okay? Okay, and so then the next term has a 2 and a 7, right? So then that degree is 9. And the degree of the third term is 0. Does that make sense that the third term is a 0? Okay, and so then the degree of the polynomial is 9 because that's still the biggest, right? The sum of the biggest, when you add up your exponents, the biggest one is what the degree of the polynomial is, just like it was before. All right, so part C, those are negative exponents. We don't want them, right? So this is not, because neither of those terms are monomials. Okay, so then this is your check. Is any of these not a polynomial? Or are they all polynomials?
A is not.
Why is A not?
It's a fraction.
Okay, so it's only not if the exponent is a fraction. But just it being a fraction in there is okay. So that one is, what's the degree of that one? 7. All right, so is there any others that you feel are not a polynomial? Yeah, they're all polynomials. Is that okay? All right, what about B? What's the degree of B?
7.
9. Why is it 9? Because 7 plus 2 is 9. What about C? 10. And finally D, 0.
Wait, how would B be 9? How are you combining the 3C to the 7th and the D2?
Yeah, so we're just talking about the degree. So it's not like we're combining them. When you're talking about the degree, you just sum up all of the exponents. Okay? So that's why it's 9. Is that all right? So yeah, if you wrote it, then you just leave it alone. Okay.
How'd you get 7 over 1 or 8?
Yeah, so we're looking at just the big, there's no, okay,
I get you.
okay. Is this okay? All right, so flip it over. Now I'm going to say this, and some of you are going to not understand why I say this, but I've been doing this for a long time, so this needs to be said. This is addition because there is a plus sign right there. Right? Don't try to multiply it.
No shot.
Okay? Don't try to FOIL it because it's addition. That needs to be said, right? That maybe you don't think it does. It does. Okay.
So that's what that symbol means.
Yeah, but right, it seems crazy, but I'm talking like 25% of people just want to multiply anytime they see parentheses. So like, I'm just gonna say. All right, now it doesn't matter to me how you guys do this. If you want to stack them vertically like that, go for it. If that helps you line up your like terms, then you should do it. I'm not going to do it that way, but you need to do it the way that you get it right. Okay? You're only combining like terms. We're only adding. Okay? So just watch your signs as you go. The book's gone through a lot of rearranging that I personally wouldn't do, but whatever it takes to get you to do it right is the way you should do it. Okay? So they give you the original here, rewrote it, and then basically they rearrange it so that the like terms are together. Okay? That's a good idea. All right, but again, all we're doing is combining like terms. So after they rearrange it, 6x cubed plus x cubed would be 7x cubed. Right, they got their x squares together, so it's 7 minus 4. So positive 3, right? So it'd be plus 3, because 7 minus 4 is positive 3, so plus 3x squared. Negative 2x minus 8x. Negative 10x. And then finally 6. Right, and you get the same answer. So whatever you need to do to get them right is fine with me. Okay, so again, the only thing that's hard about doing these is making sure you're only dealing with like terms and you got to pay attention to your signs. All right, so here's your check. Right, you should be getting 6x cubed. Again, if you want to rearrange these, super awesome. Right, that's a positive 2x squared. A positive 11x. And then that minus 3 doesn't have a like term, but you still got to write it. Is that okay? Right, nothing to it. All right, watch your signs, right? Everybody messes, not everybody, right? Every time I do it, like I can tell you to watch your signs 100 times, and some people just aren't going to do it. What can I do? Okay, so the easiest way to do this is to distribute the negative first. And I'm sure when you guys first did this, they told you to do that. But then you say, I don't need to do that. And then maybe you'll make a mistake. Okay? So I personally would make sure that I understand that I'm basically distributing this negative to everything. Oh, because of that, it is a subtraction problem. Right? It happens. All right, so then we're distributing the negative sign, and that's what they did there. Okay, and that's nice because now you don't have to minus negatives and things like that, which is what's going to happen when we do it vertically in method 2. Okay, but again, they rearrange it. You need to figure out how to not miss a term when there's this many. Okay, so they're saying, okay, well, there's no other x to the 5th here, so then we were just going to write 2x to the 5th. You're going through and looking for x to the 4th. right? 11x to the fourth minus 5x to the fourth. Again, we don't have to worry about the subtraction anymore because we distributed the negative sign. Okay, so we have 2x to the fifth. It's a positive 6x to the fourth. Minus 9x cubed. There's no other x cubed in there. Plus 10x minus 12. Is this okay? So, you can do this if you want. I wouldn't do a subtraction problem like this because then you got to think more. Okay, and I would say why? If you can just write it down differently. So if you are subtracting, you better say it. Okay, so it's 2x to the fifth minus nothing, so that's why it's 2x to the fifth, and then these would make sense. 11 minus 5 is 6. But when you get over here, make sure you think it through, right? Because we didn't distribute the negative like we did up there. So then it's 7 minus a negative 3. So that makes it plus 3. Okay, so to me, I wouldn't do it this way personally, but you can do it that way if that's what you want to do. But you get the same answer. Is that right? All right, here's your check. I'll give you a second and I'll write down the answer. Watch your signs. So right, that should be a negative 5x cubed. Positive 6x squared. Positive 3x. Positive 10. Is this okay? All right, so multiplication. I call it distribution. You can call it foiling. Actually, I call it foiling too, but right, foiling means something very specific. So it stands for first terms, outer terms, inner terms, last terms. And so all they're talking about is distributing, right? Like I just distribute. 2x times x would be your first terms together. 2x times negative 3 would be your outer, right? They're on the outside. 4 times x, those are the inner ones. They're on the inside. And then the last terms together, 4 times negative 3. And then all you're doing is combining like terms. Okay, so again, this should be review. Someone asked the other one. Yes, you should always simplify as far as you can. All right, but make sure you're distributing, right? And so that's what this one is. It's just a distributive property. Right, so we're just taking the 2x and multiplying it by everything. Okay, they really drag it out and rearrange it. You don't have to do that. But right, they got 2x times 4x to the third. And they got 2x times 5x squared. 2x times negative x, and then 2x times negative 7. Don't forget when you're when you're multiplying like bases, you have to add the exponents. And that's why this first one's going to be 8x to the fourth, right? The fourth has to come from x times x cubed. Then 10x cubed minus 2x squared minus 14x. There are no like terms on that one. Okay? So when you're multiplying binomials, right, it's very common to overdo this problem. All right? You're only doing 2 at a time. Never try to distribute to more than one group of parentheses. That's too much. So you pick any 2 binomials. Now, I always pick the last 2 just because I'm like anal in the way I write stuff, okay? So, but it doesn't matter. You don't have to write it this way, and the book doesn't. Okay, they do the first two, but whatever. Okay. So then we're just foiling 3a plus 5a. I'm sorry, 3a plus 5 and a minus 7. All right, so the first together is 3a times a. The last together is 3a times negative 7. Or I guess that would be the outer. The inner together would be 5 and a, and then the last terms would be 5 times negative 7. Right, we get negative 21a plus 5a minus 35. And then we got negative 16a there when we combine like terms. Okay, so again, you know, if you did the last two first, it wouldn't look like this, and that's why I usually don't write like that. I only want to distribute twice, whatever. It's the same difference. You can multiply in any order you want. Okay, but now they're taking the 3a, like I said, they're really dragging it out. They're multiplying the 3a times 4a plus 1, and that's how they get to here. And that means they're taking the negative 16a and distributing it to the 4a plus 1. And then they're taking the negative 35 and distributing it to the 4a plus 1. Does that make sense? Okay, and so now we're distributing it again because we have 4a plus 1 left over. So then 3a squared times 4a, 12a to the third, plus 3a squared. Negative 16a times 4a is negative 64a squared. Negative 16a times 1, negative 16a. Negative 35 times 4a, negative 140a. Negative 35 times 1, negative 35. And then combine like terms. Right, so then we get negative 61a squared here. Right, negative 156a minus 35. Is this okay? I was going to skip the check. Is that okay? Byron's my kind of guy. He's not only making cakes, but he's doing some math. He's my kind of guy. A very intricate cake. Byron is baking a 3-tier cake for a birthday party. Each tier will have half the volume of the previous tier. The dimensions of the first tier are shown. Find the total volume. What's the task? Find the total volume. How do you do it? How do you find the volume of a rectangular prism?
Don't you gotta find the volume of each one?
Yeah, so we're going to find the volume of each one, and then what are we going to do with that?
Divide by 3 or something?
Well, no. If we find the volume of each tier,
Then we gotta add them up.
then we just add them up. Okay, so then how do you find the volume of a rectangular prism?
Length times width times height.
Yeah, length times width times height. Then we'll work in the half and half the size and things like that here in a second. Okay. Does that make sense? Like what we're doing? So what's the volume of the? Like how do we find the volume? I'm gonna do this off to the side. How do we find the volume of tier 1?
4x minus 3 plus,
We're multiplying, right?
yeah, 2x plus 1. And then, or just be x.
And then just an x, right? Those are dimensions: length, width, and height. Okay. So I want to FOIL first. I'm going to leave the x alone for just a second. So we FOIL that thing. What do we get? Eight x squared
4x.
plus 4x minus 6x. Yeah, and let's combine like terms. So then it's really 8x squared minus 3. And then we might as well finish it off, right? So then 8x cubed minus 2x squared minus 3x, that is the volume of tier 1. Now they say some things about tier 2 and tier 3. So compared to tier 1, what's the volume of tier 2?
Half of that.
Half of that. So how do we find half of that?
Divided by 2.
Yeah, divided by 2, or I want to do it by multiplication though. Not by negative 2. Well, just one half, just one half. Yeah, okay. So then, right, tier 2 would be 1/2.
I agree.
Does that make sense? Of is multiplying in math. Half of the other one. Is that okay? When we distribute 1/2, what do we get? 4x cubed. What is it?
Minus x cubed.
Well, x squared minus x squared. Yeah, 3 over 2. I'm going to leave it as 3 over 2 right now. So minus 3 over 2x. That's tier 2. What about tier 3? How do you find that?
Same thing we just did, except for the numbers.
Yeah, right. So tier 3's volume is half the volume of tier 2. So yeah, it's the same thing, except we're using tier 2 now.
Cubed.
2x cubed.
What's x divided by half?
Yeah, what is it? Yeah, well, multiply by half. Yeah, what is it?
Half would be
So minus 1/2 x squared.
Uh,
0.75, so right, you're multiplying straight across, so minus 3 over 4x. So that's tier 3. Is that okay? Okay, they don't want each individual, they want the volume of the entire cake. So that means we're going to do what again? Yeah, so add all like terms. So here's a like term. 14x cubed. Right, now let's do the x squareds. Yeah, so minus 3.5 x squared. And then finally, five and what did you say?
Half.
Not a half.
Quarter.
Yeah, I think it's a quarter. So 5 1/4 x. Right, because negative 3 minus 1.5, right? That's negative 4.5 minus another 0.75. Is that okay? All right, so again, that's all the notes for this whole section. So there won't be any notes tomorrow. I'll answer questions if you got them. Right, you got, plenty of time right now. Probably get all of 1 to 19 done. That means tomorrow, if you don't have any questions, you can just roll, start on the spiral review. You can do that now, but we only got 14 minutes or whatever. So you can do some spiral review, right? Work on these tomorrow, work on these now, okay? If you got time, you can keep rolling because there's nothing going to be new. Does that make sense?
Let's talk about Will Smith.